Hello everyone, we are group I3 and today we'll be discussing about the use of address bus, data bus, control bus in von Neumann architecture. Here are the topics we'll be covering in this video. Von Neumann architecture, also known as stored memory program, is the basic model used for designing and building computers consisting of four main subsystems, namely the main memory, the ALU, control unit, registers, and the input-output systems. Now let's see what operations these subsystems perform. First, main memory. Main memory stores all the data and a set of instructions, also called as a program. Main memory consists of the following parts. Accumulator. Accumulator stores the result of calculations made by the ALU. It holds the intermediate of arithmetic and logical operations. It acts as a temporary storage location or device. Program counter. Program counter keeps track of the memory location of the next instruction to be dealt with. The PC then passes this address to the MER. Memory address register (MER). It stores the memory locations of instructions that need to be fetched from memory or stored in memory. Memory data register (MDR). It stores the instructions fetched from memory or any data that is to be transferred to and stored in memory. Current instruction register (CIR). It stores the most recently fetched instructions while it is waiting to be coded and executed. Instruction buffer register (IBR). The instructions that is not to be executed immediately is placed in the instruction buffer register. Second, ALU. The arithmetic logic unit is that part of the CPU that handles all the calculations the CPU may need. Example, addition, subtraction, or comparisons. It performs logical operations, bit shifting operations, and arithmetic operations. Third, control unit. A control unit handles all processor control signals. It directs all input and output flow, fetches code for instructions, and controls how data moves around the system. Fourth, register. Registers refer to high-speed storage areas in the CPU. The data processed by the CPU are fetched from the registers. Fifth, input-output devices. Program or data is read into main memory from the input device or secondary storage under the control of CPU input instructions. Output devices are used to output information from a computer. If some results are evaluated by the computer and it is stored in the computer, with the help of output devices, we can present them to the user. For all these operations to occur, we use a communication channel, also called as bus, which will be explained further in detail.
An address bus is a communication pathway that allows a CPU or a memory controller to identify a specific memory location in the computer's memory. It is a collection of wires that carry the memory addresses from the CPU or a memory controller to a memory device such as RAM, ROM, and other peripherals. The address bus is unidirectional, which means that it can only transfer information in one direction, from the CPU or memory controller to the memory devices. The width of address bus determines the maximum amount of memory that can be addressed. For example, a 32-bit address bus can access up to 2 raised to the power 32 memory locations, which is equivalent to 4 GB of memory. When a program is executed, the CPU generates an address that specifies the location in memory where the data or instructions are stored. The address is transmitted through the address bus to a memory controller, which selects the corresponding memory location and retrieves the data or instruction. In summary, the address bus is a crucial component of computer's architecture, as it allows the CPU and other components to communicate with the memory and other peripherals by specifying the exact location of data or instruction they need to access.
So now let's look at this topic, control bus. In computer architecture, a control bus is a part of a system bus is used by CPUs for communicating with each other devices within the computer. Control bus is basically used to send control signals or timing signals, and for this we have dedicated hardware which is control unit because for which instructions to execute. If we talk about memory, if we want to perform read in memory or write something in memory, for this we have control signals which generates control unit and timing. If we want to read something from input device and write something from the data, so for all these values control bus is used. For example, a computer CPU will use the data bus to transmit information to and from the central memory. For all these purposes, we use control bus.
Let's move on data bus. Data bus is the bidirectional bus. It provides a path to travel the data from one device to other device. When we give input to input device, it will go to data bus, and after that it will move on microprocessor. That means data will get transferred from input device to microprocessor via data bus. That input data will get stored in registers which are present in microprocessor. Then that data which is stored in microprocessor is processed, and the output data will displayed on output device via data bus. One more use of data bus is for shifting the data in between different registers like data register or temporary register. Now let's move on the length of the data bus. The length of data bus is depend upon the size of the word. Let's suppose the word size is of 2 bytes, that means 16 bits, then the length of data bus will be 16 bits. In this case, if the input data is of 1 byte, means 8 bits, then the MSB of data bus will become 0 and the LSB of data bus will set as per the input data.
Here are conclusions of the types of buses in computer organization and architecture. First, data bus. It is responsible for carrying data between the CPU, memory, and other peripherals. Second, address bus. It carries the memory address of the data being accessed. Third, control bus. It carries signals that control the operations of the computer system, such as read or write and interrupt signals. Fourth, system bus. It connects the CPU, memory, and input and output devices. Fifth, expansion bus. It is used to connect peripheral devices to the system bus. Sixth, local bus. It connects the CPU to the cache memory. 7. Front side bus. It connects the CPU to the north bridge and is responsible for carrying data between the CPU and memory. 8. Back side bus. It connects the CPU to the L3 cache memory and is used for cache to cache communication. So overall, buses play a critical role in the functioning of computer system, and understanding their different types and characteristics and is important for designing effect and effective computer architecture. Thank you.